Hi, this is Mr. Goma, and these are my hints for how to solve stoichiometry problems. First, start with the data that you're given. A lot of times students, when they see a stoichiometry problem, they want to start with a balanced equation, or they want to start with the molar mass of something. And that's not what you want to do. Those are constants, essentially. The molar mass for carbon dioxide is always going to be 44.01 grams per mole. So it's not going to help you to start there. What you want to start instead with the data that your problem is given. So perhaps the problem says start with 10 grams of carbon dioxide, or start with a 1 molar solution of hydrochloric acid. So you want to start with what you're given and not with a constant like a molar mass or a coefficient from a balanced equation. Okay? So second, what do you do with the data that you start with? Well, you almost always want to go to moles first. And why is that? Well, the reason is that the only way you can figure out something about something else in an equation is to first go to moles of what you're starting with. Because the only time you can convert between two substances in an equation is from the mole-to-mole ratio, and that would come from the balanced equation. You can never go directly from the mass of one species or one substance to the mass of another. No, you've always got to go to moles first. Essentially, there is a hard line right down through the middle of this chart here. And the only way you can cross that line is using the mole-to-mole ratio. Okay? So how do you get to moles? Well, perhaps you start with the mass of a reactant. And then you got to go to moles. Well, you can use the molar mass. You'll set that up as a conversion factor. I'll do capital M for molar mass. Okay? Set that up as a conversion factor. Obviously, if you start with mass, you'll need to divide by the molar mass to get to moles. Maybe you're given the molarity of a reactant. Okay? And if you're given the molarity of a reactant and you want to go to moles, you can multiply that by the volume. Essentially, you're going to be using M equal to moles over liters, the equation that defines molarity. Okay? Perhaps you're given P. P stands for pressure. So you're given a gaseous substance and you want to find moles there. Well, you can also get to moles. You're just going to use PV equal to nRT. That is the ideal gas law. And the N in the ideal gas law right over here, that is the number of moles, okay? So there's lots of different ways to go to moles. Now, why did I say substance A as opposed to a reactant? Because sometimes the information you're given is about a product, and you essentially have to figure out information about a reactant. Using the mole-to-mole ratio, you can go any way in an equation. You can go towards products, you can go towards reactants, you can figure out information about another reactant. So maybe substance A and substance B are both reactants, okay? It doesn't matter. You go to moles of one substance. Using the mole-to-mole ratio, you can go to moles of another substance, okay? And of course, once you're in your moles of another substance, that's when you can figure out other information, maybe the mass, maybe the molarity, or maybe the pressure of that other substance, okay? But the key thing is you got to go to moles in order to do any of these other things that you want to do, all right? So my last piece of advice, if you're solving stoichiometry problems, happens if you're given info on more than one reactant, on 2+ reactants. In that situation, you always got to analyze for a limiting reactant. Now, sometimes a problem will say this species is in excess, and then it essentially tells you which species is the limiting reactant. But many times a problem won't tell you what's the limiting reactant. You've got to figure that out. For example, if I'm making bicycles and I'm given 24 wheels and only 11 bike frames, well, it doesn't matter that I've got 24 wheels because the 11 bike frames are going to limit how many bikes I can make. I'm only going to be able to make 11 bikes with my 11 frames. Even though 24 wheels divided by 2, I'd have enough for 12 bikes, okay? So you've always got to analyze for a limiting reactant because often one of your species is going to be the limiting reactant. Often we do want to set up chemical reactions for a limiting reactant because that way that helps us figure out how much product we're going to form. How do you figure out the limiting reactant? Well, you're going to analyze which reactant produces the fewest moles of the product. So you want to start out with the moles of one of your reactants, or you start out with probably one of these pieces of information, and then go to moles of your product. So this would be substance B in this case would be your product. Then do the same thing for the other reactant. Whichever reactant produces less product is going to limit the formation of product. That's going to be your limiting reactant. So again, start with your given, go to moles, analyze for limiting reactant. Hope this helps.